Hi, everyone. I'm Harsha Hampapura. I'm a scientist at the Data Engineering and Curation section here at NSF NCAR. And welcome to the second talk in the GDEX Discovery Series. Today, I'm going to talk about the Open Science Data Federation and how we collaborate with them to disseminate GDEX data. This is the outline of my talk. I'll give a lightning introduction to NCAR's Geoscience Data Exchange, or GDEX. But if you want to know more about it, I encourage you to check out the first talk in this series. And then I'll move on to the main topic, the Open Science Data Federation. I'll talk about GDEX's collaboration with OSDF, and pause for questions later. Okay. In case you don't know what Geoscience Data Exchange is, it is NCAR's data commons. It's a major data repository, and our stated purpose is to support research in Earth system sciences here at NSF NCAR and US universities with community reference datasets that are co-located with our community accessible compute services like Casper and Derecho. If you go to gdex.ucar.edu today, you will see that we have petabytes of data, about 1,600 data sets spanning various collection types like in situ observations, analysis, reanalysis, various model simulation outputs. And we try to serve them in analysis or AI-ready data structures. GDEX is more than the web portal that serves the data. Right? The team consists of science-educated consultants who provide many other services like spatiotemporal subsetting. We provide DOI services. We let you deposit your data into GDEX if accepted, and so on. So really, our goal is to serve our data users via a unified interface that we constantly update based on user-centered design. We want to serve data according to the FAIR principles. These are findable, accessible, interoperable, and reusable. And whenever possible, we serve our data in analysis-ready formats like ZAR. And as I mentioned, our biggest strength is that we are integrated with NCAR's community accessible compute, Casper and Derecho. Finally, we are also interoperable with other major data repositories like NASA, NOAA, DOE, via the Open Science Data Federation, and we support streaming of data and reproducible workflows. And our AI-ready datasets also support rapid iteration that's necessary for AI/ML research. That's all great, but how can GDEX help you, the user? I've mentioned the unified interface and the several services like spatiotemporal subsetting, threads data server, and so on. I've also mentioned that we are co-located with compute services. But if you are a data provider, I would like to highlight that all of your data is backed up once it is deposited in GDEX, so it's resilient and it can be shared freely with your colleagues at NCAR and beyond without any ingress egress costs. So that was my introduction to Geoscience Data Exchange, or GDEX. I'll move on to the main topic for today, which is the Open Science Data Federation, or OSDF. Let me begin with a question. Have you ever wondered how it's super easy to stream your favorite movie or show on Netflix, but extremely hard to stream scientific data? Nobody needs to teach anyone how to stream their favorite show. All you need to do is locate it on Netflix, hit play, and then it starts playing. But even if you know where the data is located, you can't stream your scientific data in the bytes that you need in an easy fashion. So the Open Science Data Federation tries to solve this problem and be the Netflix for science. If you're more technically oriented, they aim to be the Cloudflare for science. Going back to the analogy, so how does Netflix seamlessly provide your viewing experience? They do this by leveraging a content delivery network or a content distribution network, CDN. And what the CDN does is it caches popular content like movies and shows closer to the user. And when a user hits play, the movie or show starts resuming from the last timestamp where they left it. So the OSDF leverages a similar network of origins and caches. I'll talk about that in subsequent slides. The Open Science Data Federation is deployed and maintained by the Center for High-Throughput Computing at the Margridge Institute in collaboration with UW-Madison. Before we start understanding the OSDF, there are two key pieces that we need to know. One is the Pelican project, which builds software platforms that can deliver data to compute platforms. In other words, it helps you deploy your own data federation. A data federation is basically a virtual aggregation of data sets. So it lets you view disparate data sets and various data repositories in a single consistent fashion as a part of the data federation. So Pelican lets you do that. They also provide two client services. So there is both a command line client and a Python client that is built on top of FSpec. And the Python client is called Pelican FS. The Open Science Data Federation itself is a global deployment of this platform. So to emphasize it once again, using Pelican, you can deploy your own data federation, but the flagship instance of this is the OSDF. They have their own protocol that's built on top of HTTP. And you might see links that in the talk that start as Pelican : 2/ or OSDF : 2/. So if you're using the OSDF, you typically encounter such links. But be assured that under the hood, it's all HTTP. I talked about a network of origins and caches. So this is how the OSDF network looks. Every O on this map is a data origin, and every C is a data cache. Obviously, the data origin contains the original copy of the data, and caches just store temporary copies of the data that a user requests. GDEX is integrated with OSDF, and it helps us democratize access to our data. It also helps us provide performant data access to distributed compute services, not just Casper, Derecho, but also the Open Science Pool, or even your laptop. And finally, it helps us easily be interoperable. As I mentioned earlier, we can easily integrate with other domain data repositories and create a data mesh. So let's understand using an example how exactly OSDF transfers data. For the purpose of this illustration, I'm assuming that there's a researcher who is working out of their laptop in a Jupyter notebook, and they have access to the Pelican client. It can be the command line or the Python client, and they are trying to access coupled model intercomparison project model output or CMIP output from AWS. And let's say they have some observations that's sitting in GDEX over here at NCAR, and they want to access these observations and plot global mean surface temperature and compare that to observations. So that's the context. The first step, obviously, is to locate the data, and you can see that within GDEX, there is a data set called OSDF data, which has this observation file in a ZAR format. On AWS, we have the CMIP6 bucket, and that we have the link to the ZAR store of interest. Now we introduce the various pieces of the OSDF architecture. There is a surface called the OSDF origin, which talks to our POSIX backend here at NCAR, and a similar origin that talks to AWS Open Data. And there are multiple origins based on where this data is located. So for this example, I'm focusing on the US West 2 region. So the data I located, the path to it looks slightly different. As viewed from the data federation, you can see that there's something called NCAR, that is what we refer to as the namespace, followed by the GDEX collection and path to the file. Similarly, AWS Open Data slash US West 2, that is the namespace or the data origin, followed by path to the ZAR store. Okay, now, using a Pelican get operation, the client requests this data, and the way this request is routed to a central service called the OSDF director, and the director is aware of all these different origins and caches. The director gets back to the client and says, I don't have, I know where this data is. And the client is redirected to a nearby cache for this data. If the cache already has this data, then the data is transferred back to the notebook and our job is done. But let's say the cache doesn't have this data. Then the cache contacts the director and asks, oh, I don't have this data. Where should I look? And it is redirected to the NCAR OSDF origin. The origin talks to our POSIX backend, fetches the data, and the bytes of data that are needed are transferred to the notebook. Using a similar operation, we can also get data from AWS. So those are two Pelican get operations. And finally, we have our nice global mean surface temperature visualization. So I just explained how OSDF works in some detail, but a little bit of history is warranted here. OSDF as a service has existed for over a decade. They're part of the Open Science Grid Consortium, and some of their services have existed for about 4 decades now, but they're relatively new to the geosciences. They have transferred data from other domains, physics data, chemistry data, even biological data, but they're slowly getting introduced to the geosciences, and our collaboration is about 3 years old. So under the National Discovery Cloud for the Climate, which is an NSF-funded initiative, several domain science projects were integrated with OSDF, and we have been working together to figure out how they can help disseminate geoscience data. And this follows the translational computer science loop. So there's the laboratory, which is the Pelican team, which deploys OSDF and rolls out services. And there is the local friendly user community, which are the pathfinders who are working under this NDC initiative. We test out these features and give them feedback. And once we are satisfied with the way things are working, we can roll out these features to the larger community. So those were some details about OSDF. I'll now move on to our collaboration. So what is GDEX doing with OSDF? If you want to learn more about this project, we have a project webpage hosted on GDEX that explains in detail about our integration with OSDF. I would like to highlight that NCAR not only has an origin, but we also have a cache installed. And this is because our Casper and Derecho users can also access data from other data repositories. And this can get routed via the NCAR cache. So that's why we have both an origin and a cache service, and OSDF lets us be interoperable with all these other data repositories. NCAR has multiple OSDF origins. There is an NCAR/GDEX origin that talks to our campaign storage or POSIX backend, and NCAR-GDEX, which talks to our object storage. So these are two different OSDF origins that have been deployed, and we also have a cache. Here is an example of NCAR's data flowing through a cache that has been installed in South Korea. Now, this is a plot from last year. Obviously, more data has flown since then. After this integration, all of GDEX dataset are available via OSDF, and OSDF is our default data delivery mechanism. If you go to any dataset landing page and go to the data access tab and click on any web download link, you will see a link that looks like this. It's an HTTPS link followed by the OSDF director, followed by NCAR/GDEX, and the dataset ID and path to the file. So the first part of this URL just tells you that this is an HTTP URL that is aware of the director. So you can see that supported by OSDF. And this is the part I'm referring to, where there's the OSDF director aware part, followed by the namespace, followed by the GDEX collection. We also serve analysis-ready data via OSDF. So if you scroll down in the data access tab and point to the virtual references or look at the catalogs that we provide, click on them, you will see that there are OSDF links in them that start with OSDF:2 /. That was the OSDF protocol that I was referring to several slides ago. In order to help users, especially our remote users, understand how to use OSDF, we have built a collection of Jupyter notebooks that show users how to access GDEX data. And these are scientific workflows, and we touch upon many representative data sets here. We also show how to stream data into other computational platforms, including commercial cloud platforms in these examples. More recently, we have archived some of these workflows and several other workflows that have come out of the NDC initiative, and in a project with a cookbook called the OSDF Cookbook. This has a detailed introduction to OSDF and has several chapters showing examples of streaming data from different origins. That's all I have today about the OSDF. Thank you, and I'll pause for questions.